Today I shall be discussing about relationship between phi, that is frictional angle phi, and pile safe load. I have already discussed about the load estimation procedure of both casted sheet of pile foundation under different provisions of IRC and Indian standard codes. Today I shall be discussing about the outcome of variation of frictional angle. I am discussing about C0 soil, that is granular soil. In a granular soil, frictional angle varies from 28 degree to 44 degree. More angular in shape and coarser the grain sizes, frictional angle move. Whereas clean round sand of loose density have lower frictional angle, which may be 28, 29, 30, like that. To this context, I would like to add here one thing. There are a reference between the relationship of frictional angle and with envelope. In some textbooks and some standards, there is a graph also. A curve is based on a frictional angle and envelope was available. This is more oftenly give some conservative values. Even sometime I find when I get phi value in laboratory test, either direct shear test or in triaxial shear test, if I am getting 38 degree in that reference with envelope corresponding that, it shall be 36 or 37 degree. That is, it is conservative. However, the effect of phi value, that is frictional angle, is very recordable impact in pile load estimation in case of granular soil. I am using the same parameters. This diameter is 1, effective pile length is 28 meter. For overburden pile length is 20 dia, that is 20 meter, and overburden at this 20 diameter length, that is the PD, it is calculated from unit submerged weight, which is coming 20.94 ton per meter square, and for surface resistance, half of this overburden pressure, so it is 10.47 ton per meter square. Now, considering same diameters, I have calculated the compressive load as 418 ton per pile. It is modified using a group efficiency factor for 2 piles in a rows, 2 piles in a columns with a space uplift load is 249 ton per per pile, and horizontal load is 36 ton per pile. Now, if we sense all other data input, basic input data remain constant, remain unchanged, only I am changing the phi value by 1 degree. It is 461 compression load, and uplift load is 267, and horizontal load is 39. If I change it to 33 degree, you see, there is a tremendous change. 562, 308, 46. Now, if we go for 35 degree, then you see 674, 347 and 52. If it is 36, immediately it is 726, 359 and 54 ton, 54 horizontal load. Now, let us see if it is 38. It is 848, 384 and 58 ton. We see the basic difference due to change in frictional angle. I have calculated for every 1 degree interval from 30 to for every 1 degree interval from 30 to 40 degree, and in this criteria I am finding here that another important factor is I am finding here that it is basically phi value has more importance in our loading capacities, especially up to 34.5 degree. You see, here I made the summary in this wise. Here it is 418, 1 degree is 461, another 1 degree it is 509, and in case of 40 it is 1005 ton. Difference is 10 degree. So in this curve, you please observe this curve. It is a very gentle curve. Gentle curve straight upward without any sense, because it is end bearing portion also there, and end bearing plus shaft resistance, both are there. So it is gradually increasing. If we consider this increment, 1 degree variation is up to 34 degree, it is 40 ton. But if we consider whole the average curve, then our variation is 1 degree variation is 53 ton. This is the total variation. So 1 degree phi in case of 30, if we consider it, if our phi value exactly it is 32, then instead of that we is using 30 degree, then there will be difference of 80 ton. So we must very careful in selection of the angle of frictional degree. We should not, most of the professionals, including myself, I am very serious. If I have to interpret some other test results, I am always taking in my hand for reserve strength, you can say it is a reserved load for 2 degree less. If I have to require interpretation of other test results, then I shall be considering always 2 degree less. But if we have some doubts, we can verify it from the standard curves given in IS, in IRC, in respect of SPT values. So let us say in my test results I say I am getting 36 degree, and corresponding n value, if I check it, if I am getting 37 degree or 38 degree, then I should adopt 36 degree. So we should not ignore there may be some error in instrumental error or human error. In the name of safety, we should not deduct any 1 degree even from the test results value, because 40 ton is not a very small load. It is a huge load for a single vial. For this lack of this 40 ton in case of 1 degree, then there may be requirement of another pile. We should try to adopt actual value for better relief to our valued customer. In this uplift load, there is a criteria up to 34.5 degree. Phi value it is 34.5 degree. Since I am not calculating here for 34.5 degree, 34.5 degree equal to earth pressure coefficient equal to 1.8. So it will be increasing up to 1.8, and gradually it will be, this will be the peak at 34.5 degree, it will be peak level, and from there at almost similar to the same conditions, but it is slightly increasing rate shall be beyond 34.5 degree. 1 degree has variation of 10 degree, and up to 34.5 degree, it is 1 degree has a variation of 16 ton. In uplift, load is generally less than 50% of the compression load, because there is a more safety factor. That is safety factor normally in case of, if it is a compression load, then safety factor will be 2.5. If it is uplift load, then safety factor shall be 3.57. So there is safety factor is slightly higher than the compression load. So 1 degree up to 40.5 degree, 1 degree variation is 16 ton. Beyond 34.5 degree, variation is 10 ton. Since earth pressure coefficient shall be 34.5, it is 1.8. In case of horizontal load also, up to 34.5 degree, it is 1 degree variation is 3 ton, and greater than 34.5, it is 1 degree variation is 2 ton. Since the horizontal load is generally resisted by the soil subgrade reaction coefficient from the upper 1/3 portion of pile head, subject to depth of fixity is equal or less than 5D, which can be calculated from the horizontal deflection and subgrade reaction factor. These are details discussed in codes, and here I have given calculation also Now you see, with this difference, with this basic difference, we can say one thing: we should not conservative. We should be little liberal in the name of safety and economy. We should not more conservative, and we should be logical in selection of 5 degree in application for load estimation in pile foundation projects. I hope it shall help you and it shall give you some little relief with this shortcut procedure. With this shortcut procedure, same material, instead of repeating the calculation repeatedly for different 5 values, you can change it by changing these values. In case of any further information, please feel free to post me at your disposal, and I am always available at jcgogoi@gmail.com. I am again saying jcgogoi@gmail.com. Please have a nice day. Thank you all.